Okay, welcome back. So let's get into the first lecture of Unit 1. So at this point, I am assuming we all have a good idea about the course syllabus, and the course content in terms of what we cover. During this lecture, we are going to talk about programming into computers, specifically introduction to computer systems, and we'll see how the computer units work together as we run a program. So in our course curriculum, so that's the bottommost layer that we talked about in the first introductory lecture. So in here then, so we are going to focus on the computer systems, specifically different part of the computer that works together while running a program, so how they coordinate with each other, right? So then in particular, so we'll try to identify important components of a computer system and then operation of these components, okay? And then understand how key components of a computer system work together while running a program. Now we'll start with a diagram that we all are very familiar with. This is a computer system we all are very familiar with. So in here, so we have few key components. The main part is showing here is the output device as a monitor in this case, and the other main component in here is the input device. So it can be either mouse or the keyboard or any other form of input device. And the third main component in here is the main body of the computer. So that's where the data and the programs are stored and processed, right? Now what we are interested in is see what is actually inside this main body of the computer, and then how the main components inside this unit works together while running a program. So let's try to open up this main body and then see what is inside it and how these components then working together, okay? All right. So when you open up this body of the computer, so essentially we identify three main components. So first we have the permanent storage or the main storage. So that's where the data is stored permanently. In general, so this is the computer hard disk, right? So a hard disk store data permanently. That means that even if we switch off the computer, so data stored in the hard disk will remain, right? So next we have the secondary storage, where we store the data while program is being executed. So that's called the main memory or the random access memory of the computer. So the one difference between the hard disk and the main memory is that hard disk store data permanently while main memory store data temporarily. Right? So temporary means, so it's called a volatile in nature. So volatile memory will be erased when we switch off the computer. So therefore it's not going to store data permanently, right? So however, a volatile memory or the main memory is much faster than the hard disk. So therefore when you are running a program, so program as well as the data is stored in the computer main memory. Then we have the main brain of the computer. So that's the processing unit. Sometimes we call it CPU or the central processing unit. So inside the central processing unit, so there are two main components. Mainly we have the control unit. So control unit sends appropriate signals into inputs, outputs, memory and the hard disk to send data as well as do processing, so at appropriate times. Then we have the ALU or the arithmetic and logic unit. So that is a part that perform arithmetic as well as logical operations that we have in the program, right? So now then the input devices as well as the output devices are connected to the main body through different input and output ports. So while let's say running a program, so we can read data from input device like a keyboard, okay, or maybe the mouse. or maybe a flash drive or something like that. Okay, so while displaying the data, once we process it, so we can put them into an output device such as a monitor, or we can put it send it to a printer or some other in output source, right? So then that's pretty much how all of these components kind of operating while running a program. Now let's take a simple scenario and then try to get into a little bit more elaborated detail about how this whole process work, right? So suppose we have a program stored in the computer hard disk. All right, so this is computer hard disk. So say our program is a pretty simple program, has two instructions, add 7, 5, so adding 2 data items, and then the second instruction is sub 8 3, so that means subtract 3 from 8. So suppose this is our program. Now according to the previous discussion, then we know that before we run this program, so we need to load this program into the computer main memory. So in here, so before we run it, so then these two units are connected. So then we take this program and then load it, right? So once you load it, so we have the 2 instructions and the data in the main memory, right? So then we have add 7 5 and then sub 8 3 in the main memory. So after putting it into a main memory, so after the loading process, so then the central processing unit, so in here, so take over the process of executing the program. Now when the central processing unit start executing the program, so what it does is it has a pointer, so that's pointing at the very first instruction in the program, okay? And then so control unit, so send a signal to the main memory to bring the instruction stored in the main memory to the control unit to see what needs to be done, right? So then the first thing that happens is actually taking this instruction and then putting it in here. So then we have add instruction, put it in the control unit, right? So that process is called the fetch, right? So we fetch the instruction into the central processing unit, right? Now after fetching this, so we need to know actually what needs to be done with this particular instruction. Now add is the instruction, CPU needs to figure out so what needs to be added and then what is the actual instruction, right? So in order for us to understand something, so this is encoded in some sort of format. So later we are going to talk about what that format is. So since this is encoded in some sort of format to give us what the instruction is, so then we need to decode it in here and see what is the meaning of the instruction. So therefore decode process that happens inside the central processing unit is to figure out the meaning of the instruction. So once the instruction is decoded, so then the CPU understands that it needs to add 2 numbers. So then it brings the 2 numbers 7 and 5 into the arithmetic and logic unit and then perform the addition. So that's the meaning of the instruction. So once we perform this addition, so we have 12 in here, and then that 12 will be placed back in the computer main memory. So then that's going to be the results of this particular addition, right? So then this process adding carrying out the operation and then putting the results into the main memory is called the execute, right? So then after doing this first instruction, so then the pointer moves into the next instruction. So we follow the same process, that is fetch, and sub will be fetched, and then it will be decoded, and then it will be executed, and the results will be sent back to the main memory to store it temporarily. All right, so therefore for each and every instruction that we have in the main memory, so we follow fetch, decode, execute cycle. All right, so then fetch, decode, execute cycle. So that basically is a process of coordinating the hard disk, main memory, and the CPU in executing a program like this nature. Now, another thing in here is that when we decode it and try to do the operation, so we bring the data from the main memory to the CPU. But it's possible that actually rather than taking data from the main memory, so we can plug the input device, let's say like a keyboard, and say go ahead and read data from the keyboard, right? So likewise, rather than sending data into the main memory, so we can actually send the output to an output device like computer monitor to display the output, right? So then this can be input, and then this can be output. So in that way, input and output units can also be connected to this process. All right. So that's kind of a much detailed view of how the units, main components of the computer, interact with each other while running a program. Another point that we want to make here is that since we follow fetch, decode, execute cycle for each and every instruction in our program, so then how long it's going to run the program really depends on how many instructions we have in the main memory. So if I write a program that has 50 instructions like this, so then we need to follow this fetch, decode, execute cycle 50 times. If somebody else wrote the same program with 40 instructions, so then that program will follow fetch, decode, execute cycle 40 times. Now, if one program has 50 times and the other one has only 40 times, then the program with 40 fetch, decode, execute cycles is obviously much faster. So therefore, while developing programs, so it's important to have more efficient constructs so that we reduce fetch, decode, execute cycles that we have in the program. So later in the semester, we are going to talk about how we can write maybe efficient programs by comparing and contrasting different solutions that we come up with in solving a particular problem. All right. Okay. So that's pretty much how different components in a computer system work together while running a program. Okay. Now, if I put it into more summarized format as to what each of these units then contribute, so we have then storage devices like permanent storage devices. We call them secondary storage devices. So we looked at the hard disk, where data is stored permanently even though we switch off the computer, right? So each of these things can be data input sources for our outputs as well as the inputs for that matter actually. Okay. Then we have the central processing unit. So that's kind of the brain of the computer. So central processing unit, as we discussed, has two main components. So control unit and the arithmetic and logic unit. So control unit retrieves and decodes program instructions and then coordinates the computer operation to carry out the operation, right? And then arithmetic and logic unit for mathematical operations as well as logical operations. So logical operations like comparison of two numbers, so comparison of a string, so that kind of instruction, right? So then that's kind of the main component inside the computer that actually carry out the execution of the program, right? So then we have the fetch, decode, execute cycle that we talked about. So first we fetch the instruction and then we decode it and then we execute it. So after that, we again follow fetch, decode, execute cycle for each and every instruction in the program. So then CPU mainly follow these steps while running a program. All right. So that's called the fetch, decode, execute cycle. Okay. All right. So then the other main component that we talked about is the main memory. So main memory is then directly connected to the central processing unit. So where once the program is loaded from the hard disk into the computer main memory, so we can follow the fetch, decode, execute cycle with the central processing unit to bring each instruction from the main memory to the central processing unit and execute it. All right. So then both program as well as the data must be loaded into the computer hard disk before we run the program. Another characteristics of the main memory is that it's volatile. So that means that the data as well as the instructions in the main memory will be erased as we switch off the computer. Okay. So the next question that we briefly look at is that how main memory is organized, and then how data is stored in the main memory. So in general, the format that main memory store data is using a binary. So when we say binary, so binary stand for 2. So then we use zeros and ones to store data in the computer main memory, as we all know, right? So then the most simple as well as the smallest unit is 1 bit. So it can be either 0 or 1. Now 8 of these bits together is called a byte. So that's kind of a commonly used term in programming. Now combining some of these bytes together, so if you have, let's say 4 of them together, so we call it a word, right? So these things are important for us to see how actually main memory is connected to the CPU. So what is the size of the data that we can take from the main memory into the CPU, and so on and so forth. All right. So later we'll take a look at that. So then at this point, so if you understand that the main memory store data as zeros and ones, so that should be good enough. And these units are then starting with a bit, and then 8 of these bits have byte. So 2 to the power 10 of these bytes is called a kilobyte. Okay. So 2 to the power 10 kilobytes is called a megabyte, and then 2 to the power 10 megabytes is called gigabyte, and then 2 to the power 10 gigabytes is called terabytes. All right. So these days, so hard disk space actually comes with terabytes, and then the main memory sizes comes with gigabytes, right? So that's, then we have plenty of memory so that we can store data as well as process nowadays. But earlier, maybe about 50 years ago, so we did not have that much memory. So memory was pretty much measured using kilobytes. So few kilobytes is considered as much larger memory space some time ago, like about 60 years ago. Nowadays, we have much more efficient memory producing techniques where we can have a huge amount of memory placed in a smaller chip. All right, so we are pretty much in this range now. Okay, all right. So now it's pretty much time for us to do a checkpointing question and then see if we understood the main components in this lecture, especially the central processing unit, the main memory, and how everything kind of work together while executing program, and then what is the unit of data storage in the computer main memory. So let's take a look at the question now. Okay.